soil and compost here at Tule Ponds at Tyson's Lagoon. One of the things that we're going to learn, if you haven't been here before, this is Tyson's Lagoon right here. It's the big pond. It's a 5-acre pond. And then these are what we call constructed wetlands. These were created by Alameda County Flood Control. And when we first got this place, there was absolutely very few trees. There was no soil cover. And as we all know, hopefully, soil is important for growing things. So let's take a look. This picture here is a little video from this area called the seasonal wetland, right in the upper left-hand corner of the picture. So let's take a look at what we do. This is a seasonal wetland in the north side of Tule Ponds. This is where floodwaters will come, fill up, and then go out to the Maui Slough via these large outflow pipes, storm drains. Now, as you can see, what we try to do is to make sure that the sediment doesn't create a jam later on, making gravity not work. We pile up the top of the soil, which, if you notice, is dark. That's because it's somewhat hydritic, which means that it
so that's why there was no trees on this area, because this area here that we just looked at is flooded all year round, or not all year round. It's seasonal, so only during the stormy. So none of the big trees can actually grow. So we're going to look, and this is what we're going to do today. We're going to look at the soil at Tule Ponds. We're going to learn how to describe soil, because soil is not created equal. There's different soils from different parts of the local area, and from the state, and from around the country. They're all different soils, and soils are important not only to Tule Ponds but for growing, but not all plants have the same requirements. We're going to look at the two soils that we have here at Tule Ponds. We're going to look at the importance of soil, and we're going to look at some soil activities you can do at home. Then after we finish this part, because it's vital for you guys to understand that compost just helps soil get better. It is not soil itself. So we're going to take a look at what soil is. First, we have to learn how to describe it. Now, soil is not just dark. It's not just any one color, because soil, as we're going to learn, is crushed rock plus organic matter. That's where the compost part comes in. And the texture has to do with how large the pieces of the rock are. If you look at this little picture here, we'll see that gravel, sand is smaller particles than gravel, and then mud is even finer grain. That means they're smaller. And then you have clay mud. You could always tell clay mud because it always kind of sticks together, and it's the mud that your parents don't like you to get in because it gets stuck in the fabric and hard to get out. So these are going to be the beginnings of our soil. So it's important to understand size, and we'll learn a little bit about that. Then we're going to learn describing soil. You got to say how much organic matter is in there. And organic matter would be other leaves, would be twigs. It would be things that get that were once living that gets mixed in with the crushed rock. We also, when we describe soil, have to understand if there's water in there or how much airspace. But it could be dried soil or compacted without air, and it's still soil. So it depends on the water and the air to see how important it's going to be for especially agriculture, growing things. Color is going to be something that we're going to look at, and it's going to mainly reflect the type of bedrock or the rocks that it is part of. So we're going to see in Hawaii, you would have red soil, because it has a lot of iron in it. And so it depends on what that bedrock or the rock, and we all know rocks come in many, many colors. And we're going to look at what it's composed of. So let's take a look at what really, I want to make sure you understand this before we go on. Soil is not just the word dirt. Dirt is just a word that we use to describe something that's dirty. Some people refer to it as soil, but soil itself is a scientific term, and it is crushed rocks plus organic matter. So that's this two, organic matter in the form of compost or other things that we're living. Now, want to make sure you understand this. Rocks are made up of minerals. Minerals are made of elements. It's these elements that when it mixes and erodes out, that the plants will need. And so that's why sometimes you'll see plants coming right out of rocks, because if the plants can get right to these elements, then a lot of times they can grow. Elements and compounds are needed for life. So there's things like, that's why when things grow from the soil, it needs water. In some places it needs the oxygen, it needs the carbon dioxide, and much more. Not for the plants, but for the other little organisms, because that's what we're going to learn about when we learn about compost. It's that compost where the living things are, and it is those animals that start breaking down the organic matter and sometimes the soil or the crushed rocks to get the animals and the plants to use these elements and compounds. So it really is more scientific than you thought. Now, let's take a look at Tule Ponds again. This is an aerial view. This is Tyson's Lagoon right in between. The red represents the Hayward Fault. So this is where it's actually moving because of the earthquake fault. But so that's why we have, we talked about that in one of our earlier ones. These are ponds C, B, and A. Now notice, this is a picture of the soil over here on the Hayward Fault side, and this is on the east side. Now notice, this almost looks like rocks, because it mainly was a lot of broken up rocks. When we first got this place, there was no soil breaking. This was the soil. It was real dry. It was very difficult to grow anything. Down here is where we have the hydritic. It has a lot of organic matter, but because it's underwater most of the time, if you ever notice, trees don't usually grow in a body of water. So these are the two types of soil we have here at Tule Ponds. Now, that's the surface. On the surface, that's it. But when you go down, and you can go down 30 inches, 48 inches. This is what we call a soil profile. And soil scientists, and yes, there are scientists, and actually they're very valuable and they're very needed. It's a good job. Because soil grows things, and you need soil scientists to understand what's going on. So if you notice this profile here, this is where all the organic matter is. And this is where we're going to find most of the organisms when we talk about the composting, because a lot of animals need air, and that they're going to have to get that from the atmosphere. As you go down you have these different horizons. You have A, which is what we call topsoil. B, which we call subsoil. It has some organic matter, but it has more of the parent material, which would be the rock. And then C would be mostly the parent material being broken down by water and all these other effects going on it. And then underneath here, we call it R. It's just rocks underneath it. So let's look at some other profiles, because we're going to look at a really little profile of Tule Ponds. Soils can be described by many different things. And so like as you're going down, we would describe, and think about how you would describe this. This one here on the left is dark. And then as it goes down, look, notice it has a lot of rocks in it. So it has more rocks than it has organic matter. And then as you go down here, this would be almost your rock, your bedrock. And then if you go to the one on the right, you'll notice that they're more fine-grained. And that's probably because there was more water here and it eroded more. And as you can see here, you're going down from more clays as you're going up to the topsoil. So, but the richest layer is always on the top. Now also notice that minerals can be described by the mineral that it has in it, or the crushed rock, the color, the particle size, and minerals that are magnetic. And Debbie will talk about that later on when we see how can soil be magnetic. Well, we're going to find out that it can. Now this is just the other day, I was looking at some old records and I found this wonderful log from 1912. So this is over 100 years old, these pieces of paper. And it talked about a rock log at Tule Ponds. Somebody from the California nursery, which is a place that we're working at, had somebody went and took a core. So this is a little core. So this is, if you can see, this is lighter than this one here. This one is the hydritic soil. So this is the one that's on the side of the Earthquake Fault. And this is the side of where the ponds are, pond A, B, and C. But it was so interesting to look at that they dug all the way down just to see what the soil was. What were they looking for? They were trying to figure out if there was water down there and if they could get the water, or would it be just a good place to grow things? And it was neither. Now, so this is our how scientists actually look at it, and how when they go in the field, they then take it back to do more tests on it. So this is, I found this in our archives. This is from the 1970s. This is a soil scientist, Kay Berstrom. And what she did was she took little specimens at different inches, and then she'd go and compare the different types. And then she would make a soil profile in the whole area. It's actually kind of complicated, but they can actually look at below how the soil has evolved through time. Now look at over here. This is what you can do. A soil scientist would do it like this, but students can also get a different soil when you walk around. What we have the kids do, you can get a popsicle stick. You can get a little jar and make some mud out of the soil, and then just rub it onto the soil and say where you got it. And then you can compare it and contrast it. And then this is how you can start learning that there's lots and lots of different soil all around. So now we're going to go to
Hi everybody, it's Debbie. I'm back here in North Carolina. Just wanted you to get an idea again of Lake Norman that's behind me. This is the Catawba River that is dammed up along the way. It's also our watershed for our drinking water. Storm water goes in here. You'll see we've got some people out there goofing around on a pontoon with the tube. And then this is Pickles that's going to go get the stick for us. Now it has rained the last couple days and it's been colder than normal, so a little bit chilly. I'm gonna go over here. The water's come up. It was below. You could see the sand and all here, but now it is hiding under the water. So come on over, see if you can get a look and how clear the water is though. Can you still see the sand under there? All right, again, if you look along the rocks here, these are granite rocks. So that's our parent material. That erodes over time. It's broken apart into smaller pieces. That again is our parent rock, gives us our sand. We've got our red mud and all underneath here as well. I'm just gonna put my, hi Pickle, are you helping? Okay. I'm gonna get a little bit of shovel full of sand here, mud, dirt, see what we can find. And I'm just gonna put it right up here. Pickles, what do you think, Pickles?
Okay, so Debbie has just taken some mud out of the lake. Now remember, this is not soil. We're looking at how soil is being made. And so the mother rock was, or the parent rock, she used the word, you could use either mother rock, parent rock, or just rock. It was granite. And now it's breaking apart. So let's look at what she found.
Hi everybody. All right, we've got our shovel full of soil here. Let's take a look and see what we've really got. Let's see, it looks like lots of sand particles. Again, I've got some of the pieces of granite that have eroded away. That would be fun to look at with a microscope. So I see a lot of sand here. Now if I make a patty cake, kind of a big ball, that's another thing about the texture of this. It's got enough moisture in it, of course, it's going to stay in a ball. It does fall apart some, breaks apart. So there is a lot of air still in there, again, between the grains of sand and all. Let's keep digging. Oh, look, here's a clam. Pickles thinks it's a treat, something she wants. Here, Pickles, let's rinse this off. There we go. So that's a sign that we've got some organic material. So we do have some plants and some animals here. Right along the edge here, you do see we got small little plants that are in there. I'm gonna keep digging through this and see. Oh, here's another clam. Now, if I can't open it, that means the animal is still in there, and I'd throw it right back. But no, this one's already gone there too. Here's a bigger one. So again, this is going to be straight from the river's edge. Now, I've also got a magnet. Let me get out this magnet. Look at that dirt right there. See where it's got the darker color? Now, I've got a big magnet. Pickles always wants to be in the picture. Oops, big magnet, just to prove that it does indeed work as a magnet. I've got just a bottle top, so you can see it is indeed a magnet. So what happens if I drop our magnet along the bottom? So if my bottle cap was down there, I'll put that down in there too. Make sure that we are indeed magnetic. Let's see what we pick up. Here's our bottle cap. So here we've got a bunch of iron. Iron is naturally magnetic. See how it's got the magnetic pattern going there. Now, why did I put my magnet inside a bag? Because you can't ever turn magnetism off. If I wanted to be able to clean my magnet again, I'd have to just sit there and shuffle and shuffle and shuffle. So this way, all I have to do is simply take my magnet out of the bag. Let's see if we can get our magnetite to drop down onto this container. Whoa, there we go. You see now, it doesn't have the pattern. I'll put my magnet back up here again though. See how strong, this is a super strong magnet. There we go, so now it's gonna stay. So we have magnets like this because usually when you're working around the lake, unfortunately, we do tend to drop tools and all down in the lake. Odds are that you're supposed to keep your keys and all safe, but sometimes accidents do happen. So that's why you always have a super strong magnet. So again, here at Lake Norman, we do have a lot of iron, that red clay kind of soil, and a little bit of magnetite in it. So get your own magnet. You can try this at home too. So that may be
I just want to emphasize too, remember guys, we talked about soil is crushed rock plus organic matter. So magnetite is a mineral. And remember I said rocks are made up of minerals. So this is one of the minerals that came out, magnetite. Now magnetite is made up of two elements called iron and oxygen. Okay, iron oxide. And so when it, and a few other things. So when it breaks down, then it gets the iron ions into the soil, and then that's what some of the plants actually use. So it's, again, chemically complicated. You got it? Can we get Debbie?
Yeah, I can keep talking. Can you guys hear me?
Yeah, we can hear you. We can't see you.
Okay, well, I'll go ahead and talk. I just wanted to mention that that area has water covering it seasonally. So just like your seasonal wetlands at Tule Ponds, it's not the best location for plants to grow. It's an area that's got a lot of the silt and clay as well as just the sand. So when you were looking at that sample, you were seeing the large grains of sand. So as a soil scientist, I would make a soil card. And of course I would describe the location. I would say it was Mooresville, North Carolina. I would describe as much as I could about the topology, like I got it from the edge of the lake, that there was some vegetation, seasonal water. I would describe the sample itself, saying that it was sand grains, large in size and colors. I would be making, the colors were red, black, and clear. I'd also mention the freshwater clams. And again, just like the soil sample card that you saw before, you could take and kind of make a little mud slurry and place it actually on the card itself. Or you can even do something like this with a little bit of some tape, something like that. So again, you have record of it. So you want to record as much data as you can as far as that soil sample. All right. Just remember that with this basic rock, you have several other things. You've got climate, organisms, relief, where it is on the world, I guess, and the parent material, and time. It takes all of those things to make those rocks become soil. So it happens over a very long period of time. So there you see a good soil sample card where we've just kind of made a little muddy slur and it'll dry off. But then that gives you that, so you can again look at that under a hand lens or a microscope. And again, the soil that you're looking at in your own backyard is going to be different than what I have in North Carolina, or even what's different at Tule Ponds. It's all been, again, changed over time. Some mud, some of the dirt and the soil may have been brought in from other locations. It may have been turned over a lot. Again, all of those are factors that determine what that soil is. But that's why at Tule Ponds it was so important to plant native plants, because we know that those native plants would do well in that type of soil that we had there. We didn't need to change it to make it be any different. There's, again, plants that were adapted for that soil. And that goes the same everywhere. Okay, Joyce, back to you.
Okay, so now that we got soil down, or we got what soil is, we want to turn our attention to composting, and how when you compost an area and then start growing your native plants, then it starts blooming. Like at one time, this area would have had lots and lots of trees, but because California, the Bay Area, doesn't have as much water or storms as other places, when you cut down the trees, it's hard to get them back. So we're going to take a look. This is a picture of Tule Ponds in 1996. Notice there's no trees. There's just kind of weeds. This is an area where people used to ride their bicycles over, and not much biological life, not like we have today. And so this is a picture of that same area a few years ago. And you can see the trees are growing. So what we've converted is you just don't plant a tree without making sure your soil is good. So now we have enough, we've created enough compost or organic matter mixed with the soil that it now could sustain these big trees. So now we actually have to cut trees down, because within 20 years or few years, it goes from here to these big trees. So now we actually have to cut things down because our soil is so rich for our native trees. So now we're going to learn something about composting. Like a lot of people think, oh, composting is easy. You just throw some garbage, some food waste, and it'll make compost. Not true. Oh, compost, oh, I'll buy that compost. Oh, and I'll get the cheapest kind of compost. Oh, and then I'll grow stuff. Compost is not soil. Things do not grow very well in plain old compost. You must mix it with pre-existing soil. And, oh, soil is just from worms. Well, no, we're going to find out that the majority of our composting actually comes from these little bacteria type organisms called actinomyces. So we're going to learn about hot and cold composting. We're going to learn about the organisms that promote composting. This is important, from the worms to the ants to all these other little organisms, and the importance of composting at Tule Ponds, and then some activities that you can do at home to learn more about composting. So now let's take a look at another part of
composting. Takes a kind of moist area. The organisms require water, and many require shade. If they dry out, their whole system will not survive. And so at Tule Ponds, the more we've got shade, the more we had natural composting. Underneath us, little animals
And I call it
are
magic
doing their
because
magic.
they can take those elements that we were talking about from the crushed rocks, and they need them to survive. And so you've heard that we need iron, that our body needs calcium to grow bones. Well, these organisms need the same type of elements to grow. So let's look at composting basics. There's two types of composting: cool and hot. Cool takes a long time and requires many organisms. A lot of times when you get compost in bags, they're getting old vegetation and putting it in what they call windrows, and then letting nature, and they will rotate it so the air gets in there. And then there's another type called hot composting, and that's what where the children in this picture are doing. They're looking at some hot compost over in here that went through a big a long project of getting hot over time, and not because we cooked it, but because the organisms released heat from their body, and then that quickens the compost, as we'll learn. That is called thermophilic. Philic meaning like, thermo meaning heat. These are organisms that like heat, but they wouldn't be worms or ants. Those don't like hot. And so those would be our cool composting animals, as we will learn. So I'm going to sing you almost a little story. Well, it's a poem on compost breakdance. And then this way we're going to talk about more about the composting as I read the poem.
This is a poem called Compost Breakdance. It shows little organisms are eating and dancing and having fun as they break down food to produce compost for us. Cool composting starts organic matter in a heap, food waste, leaves, at least 1 meter deep. This slide is showing us that a traditional way of piling food and leaves and letting the organisms slowly do their magic. They need still air and moisture. The bad thing is that it releases methane, which is a greenhouse gas. There are many pathways different organisms take. The product compost is what they make. Cool composting takes time to collect. Organisms eating creates this brown effect. So as this is going through their system, they eat, they poop, and then the nutrients they get from what they're eating gets kind of put in their poop. And then as they're going around, they're making tunnels and they are mixing it, creating that brown effect. Other cool decomposers, ones that you know, pill bugs, ants, millipedes, help plants to grow. So there's other organisms that are involved. This is a millipede here. As it's going through, as you can see, it's making air spaces. And so as it's eating, it's producing our compost. Annelids such as worms, important to be found. Long poop trails nourish soil underground. If you look at this little picture, that worm is pooping. Food goes in and poop comes out. So it's like a little chemical compost factory. And if you look on below, the little black spots tell you that's poop. And so they're aerating and pooping and creating that compost. A decomposer's dream is to break things down, whether hot or cold. They make food brown. So this goes back. They're always working. They're always doing their job. Hot composting is needed if you want compost quick. Heat produced by microbes is the chemical trick. Thermophilic compost. Actinomyces produce heat. By munching on nutrients, nitrogen, carbon are a treat. Now, if you look at this little organisms, the little pink things are the microorganisms and the orange. And what they're eating is they're taking up nitrogen and carbon and they're reposing it into other useful parts. Many medicines produced by actinomyces, a bacteria in hot composting, giving off heat as it eats. Actinomyces are responsible for the earthy smell. Composting is complete and all is well. This picture is showing some of these microbes. These are electron scanning microscopes, so they're very small, but they are doing their things. Many, many medicines do come from these little organisms. A decomposer's dream is to break things down, whether hot or cold. They make food brown. Again, still doing their magic, even as we are reading this presentation. Decay produces nutrients, whether hot or cold, available for other plants, microbes, and mold. So a lot of this material that they're composting and breaking down, the nutrients and the elements are available to the plants which need them to grow. Compost by itself is not enough. Must be mixed with soil to make magical stuff. Crushed rock and organic matter makes rich soil. Compost is nutrient rich, not just food to spoil. So remember that you just don't put food waste. That will produce anaerobic composting, which just stinks and is not good. So you need to follow these methods that we'll be discussing later. Decomposition is essential to the entire food chain. Dead things are broken down. The life cycle can sustain. So this is not something just minor. This is an active part of all the life cycle. The little ones have to help support the larger as you go up the food chain. A decomposer's dream is to break things down, whether hot or cold. They make food brown. Sing it with me. A decomposer's dream is to break things down, whether hot or cold. They make food brown. Now, this is the essence of our presentation. Decomposers of compost. All of these animals throughout the food chain have their purpose. But remember, this is a food web. It goes in many different areas. The little cards that you have will help you try to figure this out.
So later on, Debbie will talk about making those cards that we made from last week. And if you weren't with us last week, you can still get those cards online. And those other ones that were not insects are all decomposers, but most insects are decomposers. But if you look over here on this chart here, and you'll be able to download this picture, see the actinomyces, these little bitty things? Now, I wanted to make sure that everybody knows what earth smells like. It's got an earthy smell. It is exclusively from this organism here. That means it is healthy. When you get that smell, because these little guys, they're all over. When sometimes you see white things, you might think it's you're not sure what it is because you can't see them. You just can see the white. You can't see what the organism is. They're all over the place and they are breaking everything down. Very important. Okay, now let's take a look at Tule Ponds now and see how we compost. When we first came here, the soil wasn't very rich with what these trees needed. So we had to come up with some kind of way to make the soil rich. So this was one of the ways.
This pile of leaves almost looks like an erupting volcano as the smoke comes up, telling us that there's some heat in there. If you put your hands inside, it's warm, and that's because the little microorganisms are doing their job, eating and releasing energy And we're
Or
seeing
really
it
it's
as the
steam, but it
creation
looks like smoke.
of smoke.
But it makes it hot. And then what's happening is this pile, if you ever notice a pile of leaves, if you leave it there for weeks, it will reduce in size. And so it's important to realize that these piles are also using these little animals to go make compost. So this is what we did at the very beginning. I just got a lot of wood chips all over the place trying to get the organisms back. You have to make the soil healthy before the trees can grow. Now, let's take a look at some of this healthy soil I'm talking about.
This is looking some more at this compost. We can see the redworm, which is a native worm to California. And we also notice just lots of other bugs just rolling around, doing their magic. You can see the ants. As he's pushing it around, you could see a lot of things moving. The ants are bigging, oh, I think that ant is moving in
And if you
pupa.
notice,
We
guys,
must have
there's like a
disturbed
blight
nest.
over here. Those are all little actinomyces on top of stuff. So they're breaking it down without you realizing it. But so they're working 24/7. These are organisms that we really need. Okay, now let's take a look at some more. These are worms. Worms are very important. And if you notice in the background in here, those are some of their eggs. And these are actually two worms. They're producing eggs right now. But what we're doing is that our soil, when we first came here, there was very, very little worms. And then as the soil got richer and richer, then these little guys are eating the plant matter that's available, pooping things out, and then aerating. So worms are very, very important to soil. Just like last week when we talked about ants. Now, food chain in a compost pile. That picture that I showed you before with all the food web, you have to remember that you have to have the organic material. That would be your organic residue. That's the bottom of the food chain. Then you'll have the primary consumers. So these are animals or bacteria like actinomyces. That's the real important one. Other bacteria, fungi, which are mushroom type organisms, slugs. These are animals are eating this plant remain. So then they are then in turn eaten by secondary consumers. And these are things that are bigger like mites and nematodes and protozoa. So they're eating other things that are eating smaller things. And then you have the top of the food food chain on a compost pile, and those would be your tertiary consumers. These would be your centipedes, your pseudoscorpions and other beetles, big beetles. And so this whole compost pile is its own little city. So let's take a look at that picture again. And this is what will be online by next week. We have this organic. So this is the first part of the food chain at the bottom, the organic matter. And then notice that you have the bacteria, the actinomyces, and fungi. Now, fungi are not plants, guys. These are its own kingdom. They also break down by another chemical way. And they are the bottom. They release heat, kind of like body heat as they're eating and giving off heat or energy. And then as we're going here, that we have the other different webs. So this is called a food web, not necessarily a food chain. A food chain is just going one way. This is the whole ball of wax. It's just all working together. And notice these are the ones that can do hot. They also can do cool, but they take much longer. So we're going to learn here at Tule Ponds, when we had to put down just the the wood chips, it took a long time. It almost took 10 years before our soil was good enough. But now we've discovered other ways to make it hot, make it go faster. So again, these are the worms. These are our primary consumers, the ants. These are the actinomyces right here, the fungi, and other bacteria. These are at the beginning. Okay, now we're going to take a look at cool composting. This is in the back in the butterfly meadow where we have our composting operations, because we mix the compost with the soil, and then that's how we start making our baby trees.
It's our cool composting area. Art is getting ready to move it over to the other area, so then we can have a lot of good compost. But this cool composting, this has been here for over 2 months now. You can see it's still kind of dark, and it's still very good, but it took us 2 months versus 2 weeks.
That's our cool composting. We're just putting leaves and some food waste, but not a lot. We mainly use this is called a jar composting, and we're going to learn how to make compost the hot way. It is really a chemical mixture that we're putting together in order to produce compost quickly.
Now we're going to make some compost. Art has food waste in there. So notice we have 1 part food waste. So he's going to dump it into the container, and he's going to get it all in there. Then the next thing, so that's our food waste. That's providing nutrients that we're going to break down. But if we just left it in there, it wouldn't work. We need a source of nitrogen. And so if you look at this, this is our horse manure. So he's going to mix that in with the food waste. Then the other thing it needs is carbon. So we use just plain old wood chips. It has to be small, can't be large, and he's going to dump that. So this is our 1 part food, 1 part horse manure or nitrogen, and 1 part carbon. Then we're going to, so August, do you want to bring that a little bit so I can see the inside of it there? So if you notice in there, it looks just brown. Yeah, but you can start seeing the food waste. We're going to add a little bit of water and then close it up and then aerate it. So we're just going to put a little water in it, and we're going to close it down, and we're going to let chemistry do its magic. So we're going to have to aerate it, and that's what Hagos is doing right now. And we'll be, within a week to 2 weeks, it'll be ready to go as the compost that we've seen.
Like I said, that's how we do our food waste composting to get it quickly. So here we're looking at it again, and I want to show you how we know that it gets hot. And this is the thermophilic. Remember, philic meaning like heats. Mesophilic means that it is half warm, like lukewarm. So let's take a look over here what Hagos is doing.
We're turning the compost in there to get the air in the area. Now we're going to stop it. So stop it, and then we're going to open it up. So open it up. And when we look inside, there is lots of compost being created. Now we're going to take the temperature of it, and how we're going to do that is Art's going to put in the thermometer, and we can start measuring the temperature. So it's cooled off, so now we know it's ready to go.
It would go up to 140 to 160 degrees. So now what's the next step is we then have to take it
out. We're going to dump the compost that we just created, and we're just putting it in a container. And then we're going to bring it, Art's going to bring it to the pile that we have, an active pile that we mature the areas to. So let's walk over with Art, and let's see our compost pile over here. So as we walk in here, he's going to dump it in, and it will stay there for about 2 months, and
Now,
then
I know you
our
guys can't
compost
smell
is
on the
ready to be
internet,
used.
but that pile does not smell. If we just used food waste, it would be so stinky that the people that live around us in their homes would be very mad. Because methane, if you remember that first slide on the story, it had methane coming out. Methane is a stinky thing that if you don't do hot composting, that you have to deal with. And so this is a perfect way to make compost at home. Now, why is compost important? It reduces the volume going to landfills, very important. But it also, most importantly, it puts nutrients and it increases our soil quality. And it adds those nutrients to the soil that we need to grow things. Now, Debbie, are you with us? Is Debbie with us? No? Yes? Because remember, Debbie is going cross country right now. So, well, she's going to add some of the compost organisms. So she's going to show you how you can look for these organisms at your house. This is her place in North Carolina. So let's take a look.
To go.
Okay, so for some of our materials that you might need today, you could use a shovel or a little trowel. You could even use a spoon or fork or knife. I do have some plain index cards and some tape. And if you remember from last week, we also have our insect identification cards. So we're going to be using those. So your job is to see if you can take a hike around your neighborhood and see what you can find. Look at the different types of soil. So I'm going to dig right here. Look at this big leaf pile and stick pile. This is an old garden bed where we had some flowers that were growing, and we just covered them up with all the sticks and the leaves. Let's see what's happened. Come on in here. Let's see. So if I dig down, move these leaves. Oh, look at what I'm starting to see already. Let's see. We've got some worms. Now again, worms can't hurt you. They don't have little mouths that can get you or anything. So you can find those, and so this is where you'll use that classification chart. We'll see what things we can find. Now, if you look at this soil, so this is that same parent soil. It's got a lot more organic matter in it, compost and all, but you also see all the roots from the trees and the plants that were here before. So again, there's some rock that helps with the aeration. But again, we've got a lot of organic matter in here. Oh, let me snag this little one. Oh, did I get him? Oh, here, I'm trying to find this little roly-poly. There he is. There, that's a little roly-poly, or a pill bug. Those are actually crustaceans. They have gills, so they have to be where it is a little bit moist. So that's why he's like here in the shade underneath all these leaves and all. Again, these are great little pets to have if you want to make a little terrarium and keep these in there. A lot of people that have other pets, they'll use these to clean up after their frogs and turtles and all. All right, let's see what else we can find. Now you won't find any, you won't be able to see the funguses, bacteria, those things. You'll just see some of the larger animals. And now you also, if you've got a hand lens, something like that, you can also use that to help look for things. And you can, if you find something, you want to put it in a little tub, you can do that as well. All right, let's keep looking. Okay, I think I am here. Can you hear me now?
Yeah, I'm just going to start playing your second one.
Okay, go ahead. So here we are again at another part of the garden that has a fair bit of organic matter. And you look at the profile here, just a little bit of the soil that's on top. See how these are little chunks? Okay. Now we also have some other organisms here. Now again, real easy thing to do is just simply put it in a little top like that. Now look at your cards, your insect classification cards. We included ones that are not necessarily insects too. See if you can figure out what this one is. I love these guys. It's kind of cold here again, so it may take them a minute to wake up, kind of warm up. You guys know what this is? Yeah, it's a slug. It's like a snail that doesn't have a shell. And if we can get him to wake up, he's got some antennas. Oh, there his antennas are starting to come out. So again, this is one of our larger decomposers. No, we just pulled it back in. Okay, on your insect identification cards, there's also a snail. So the soft squishy animal is inside that shell. The animal is the one that makes the shell. As it grows larger, it makes a larger shell. And again, it's similar to the group of the slugs, where it is simply a decomposer. So its job is to break up all this leaf matter, make little holes in the ground so there's more air to get through, leave their little poop trails. I'm going to put my little slug back down in here because again, I want him to stay where they live because this has got all the things that he needs to live there. I don't want to take him away from his home. All right, so again, for this soil, you can see it's pretty crumbly. So it's the red mud with a little bit of organic matter. You see the big leaves and all in there, but it doesn't really stay together. It's not very moist. Okay, so for ideas as far as things that you can do, kids, you get the idea that you can make a soil card. I could have made one for both of these locations, but wherever you decide to go, if you have area around your house or if you have to go to a park area, you can make a soil card for that area. And then as you're looking for any organisms that are in that area, we've got our insect identification cards that we used last week. We made them with the ant trails story, so you can go to our website and find that link, and you can make those as well if you want to. But remember last week when we were talking about the ants, a lot of these organisms, the metamorphosis that happens. So when you're digging through the dirt, you may find the egg cases, you may find the pupa, so you may find a lot of different things. That's why on this big decomposers chart, you see so many different parts. Again, you'll see a lot of different parts and pieces, so you may have to look things up. As you get used to digging around things, you'll want to use your hands more, but at first, if you're not sure what the organisms are, that same index card that you use to make your organisms, your insect classification cards, or that you use for the soil, you can use that to even scoop up your animals that you're finding, your organisms that you're finding, to put them into a smaller tub or container to look at. That way, if you're not sure if it's a safe animal to pick up, and of course we don't want you being bit or stung by anything, so you could just use a little index card to kind of scoop them up until you get to know your animals a little bit better. The only things that I have in my area that I really have to watch out for, remember, are those ants, the big fire ants. Those are a problem. Spiders, I don't really even have to worry about much those either. Sometimes I have to look out for the centipedes because sometimes the centipedes can bite. But again, especially those isopods, those little roly-polies, those are a lot of fun. And there's so many different varieties of those that you can find. They come in all different sizes and colors. So those are a really fun organism to look for. So that gives you a couple ideas, a couple things that you can do. Remember to go back, if you weren't here last week, you can go back on our website and find the ant trails class and look up for those lessons. And for this week, again, if you go to our front website, the front page that has on the bottom, it'll have a link to all of these activities and cards that you can print out. And there we go. And also for next week, we've already posted the amphibians and reptiles that at Tule Ponds, and you'll see the codes that are there. So everybody should be ready to go for that next week. That'll be Friday at 11. And we'll go ahead and see if we can get a couple quick questions, if there are any quick questions that you guys have.
So if you guys want to ask questions, Habos will unmute you so you can ask any. Any questions? Just raise your hand. Anybody?
Yes.
Okay.
Anisha.
Okay, Anisha. Okay, so Anisha's first. Can you talk, Anisha? Do you have a question?
Okay, so
What's your question?
yeah, how do you get that card? That
Oh,
how do you print out in the side? How do you print out the card?
okay, you would go, you see on this page here, we have our website. and you can go on our website, and on the front page it says activities for
How
field
do you
trips
print
online.
out the card?
Oh, do you have a printer? Hopefully you have a printer and you'd be able to print out. Otherwise, what you can do is either email me um, or Debbie or Hagos, and maybe we can get it to you. Maybe you can come by Tule Ponds. Actually, guys, in a few weeks, we
No.
are going to open up Tule Ponds, so some of you guys can come on with your family and take a walk. So that would be a time when you can maybe get those cards. But they are online and you'd have to print them out. And if you don't quite can't find them, just email one of us and we'll gladly send you the link. Okay?
And the other thing too, if you have access to a phone with a camera, if you want to take a picture of your organisms that you're finding around your house, and then bring those, and we can try to help identify them when you come to Tule Pond.
Yeah, Debbie will be here next week, so she's going to be available for people to help out. So you guys can do some exploring, and then maybe we can get some help. Okay? Any other questions? Huh? Oh, Russell. Is there a Russell?
Yes.
Okay, what's your question?
No.
You don't know? Okay. You can make up a question. Huh? Annika? Harika. Harika, go ahead.
Where is Tule Ponds?
Oh, Tule Ponds is in Fremont. It's where do you live? In what area?
Ardenwood.
Oh, Ardenwood. Okay, do you know, ask your parents where the Fremont BART station is. And we're right behind it. We're at 1999 Walnut Avenue. When we do, yeah, so we will send information out. We'll have a special on our website. We do have directions, okay?
Okay.
Okay.
Thank
Okay, one
you.
more question. Misha. Misha, do you have a question?
Oh, okay. I don't have a question.
Oh, okay. Do you have a comment?
Okay.
Okay, guys, well, thanks for coming. Remember, next week we'll be amphibians and reptiles at Tule Pond, so we'll look at the animals that are here. We'll also do some little background information about what's the difference between the amphibians and the reptiles. Our little peeper frogs are coming out. We're hopefully going out and take a look at them, and they're just coming out in their habitat. It's perfect right now. Okay, guys. Thank you for coming, and we'll see you next week. Bye-bye.